Hello students of MR 2300. Today, this is Mr. David and I'm going to discuss Unit 9, Sampling. Okay, so let's get going. Okay, so the lessons or the objectives today are identify the key elements of a sampling plan, distinguish probability and non-probability samples, calculate sample size for industry using various approaches. So evaluate sample size, identify and discuss sample errors, and differentiate sampling and non-sampling errors. Okay, and describe how response rates can be improved. So thinking about your final project, your research project, there really wasn't a sampling plan done. You were told that you had to send your survey to all MR 2300 students, okay? And that basically was your sampling plan. And we did that just to make the final project, I guess, doable for you in the timeline that we have. But this sampling is very important if you ever do market research for your customer, or a client, or you do market research for your company or HR research. You need to understand sampling plans. Okay, so some basic concepts. Population, the entire group being studied as identified by the research. So you think about the entire group for your research project, we were using the School of Business students. Okay, in the real world, your population could be all the potential shoppers at a mall, okay, or all the potential customers for Lulu, a location, or in general Lulu in Qatar. Everyone of interest in a specific group, that's the target market, okay, the people of interest. Census, survey of everyone in the population. So the governments usually do censuses, and Qatar did one, I think a couple months ago. And generally it's only governments that do the census, where they want to know something about everybody in the country. And then sample, a small group in the population that should represent the population. Represent means the same demographics, lifestyle, attitudes, behaviors as the population of interest. So when you chose, or we gave you the population of the School of Business, and we told you previous to here, the group that you were going to sample were MR 2300 students. Okay, that was a sample, but we still wanted to make sure if your sample was valid, the actual people who answered your survey. So we used whether or not they were Qatari, non-Qatari, and if they were male or female, and then compared that to the School of Business population. Okay, and there's a slide on that that Ms. Karen went through in a previous video. Okay, so why sample? Why do we sample? Why do we pick a smaller group of people out of the larger population to ask our questions? Well, it costs less. You get results quicker because you're only getting 30 surveys instead of 2,000. Only government can afford a census, so it's expensive. If we were to ask everybody, could you imagine how long it would take for you to collect 2,000 answers or have 2,000 surveys completed? Only a government can afford that, get all the people out there working for them to collect all the data. And samples, collecting a small sample of 25 to 30 people can actually be very accurate. Okay, so sampling methods. There's two sampling methods. There's probability sampling, and that means, right here, each member of the population has a known chance, probability, of being selected in the sample. And an example of that is a simple random sample. Okay, so if you think about your MR 2300 survey you did with a business school population of 2,000, if you went around and asked every 10th person you saw in the School of Business to do your survey, that would be a simple random sample. Or if you got all of the email addresses, lined them up in order in Excel, and emailed every 10th person, that would be a simple random sample. And then on the other side, we have non-probability sampling, where chances, the probability of selecting a sample from the population are not known. Okay, and that's called a convenience sample. So which do you think was done for your MR2300 project? A simple random sample where everybody had a known chance of being asked, or was it a convenient sample? Well, the answer is it was a convenient sample. All we did was send emails to students of MR2300. None of the other business faculty students had an opportunity to do the survey. Okay, so we did a convenient sample. Simple random sample. The probability of being selected in the sample is known and equal for all members of the population. We can calculate the probability of choosing each person if we know the exact number of the population of interest, and we know that. We know the population of the School of Business. If we can contact these people in the population, so if the registrar were to give us all the student numbers, and then we were to get permission to email all those people, okay, and we have a way to choose the sample from the population, so maybe every 10th person from that list. But we did not have the list of student numbers, so we could not do a probability sampling. Okay, we only had access to MR2300 students. Okay, we want you to conduct a survey of current CNAQ students. Okay, is a simple random sample possible? Okay, so is it possible to do a simple random sample of all CNAQ students? Yes, it is possible if we get cooperation with the registrar and probably the president's office to do a survey. Can we identify the total number of current students? How can we identify how many students there are at CNAQ? Well, the registrar. Okay. Can we contact the current students? Well, right now, no, we can't. But if we were to get that permission, we could. How can we choose the sample in a random way? So say you actually had permission to do this survey to all students across CNAQ. How could you ensure that you randomly selected this sample? Okay, as I said earlier, if we were to put it in Excel and we were to select every 10th name or every 20th name or every 30th name, whatever it is, that would make it random. Okay? How about in this class? So think about your particular class. Maybe there's 18 students. How could you randomly select 6 of those 18 students? Okay, again, you could put all the student numbers in Excel, pick every 6th student. Okay? Okay, Apple wants to measure the opinions of Qatari consumers toward their new iPhone product. Can Apple get a list of everyone, I mean everyone in Qatar that has a new iPhone? Can Apple get that list? Can Apple select a simple random sample and then send the survey to this group? Okay, so the word everyone is key here. No, Apple cannot get a list of everyone in Qatar that has their new iPhone. Okay, because some people bought iPhones for other people as gifts. And not everybody has necessarily registered that iPhone yet. Okay, so it can't be everyone. It might be 99.9%, but it can't be everyone. Okay, can Apple select a simple random sample and send the survey to this group? It depends on how they're using their phone. So if everybody has set up an Apple account, if everybody had set up, say, some of the Apple apps and had their email registered in there and had given permission for Apple to contact them for marketing purposes, then they could generate that list and create a random sample from that list. Okay, but that assumes a lot of things. So more than likely, Apple is going to select a convenient sample of the people they do have and then randomly select within that sample. So it's still not a simple random sample. It's a convenient sample where they might randomly select some people. So there's a difference. And the difference is, do they know absolutely everyone in the population? Okay, so doing a simple random sample is not actually that easy because you need access to everyone in the population. So what Apple would be doing is probably an incredibly incredibly accurate convenience sample that almost perfectly matches the population, but it doesn't 100% match the population. Okay. Simple random sample. Advantages. Everyone has an equal chance of being selected. Removes human bias. That's some of the assumptions we might make in selecting the sample. So a human bias in selecting a sample. You went around and asked only your friends to do your MR 2300 survey. That would be a bias. Okay. When you went to the mall, you only asked people that had a smile on their face because you thought, oh, they'll be friendlier to me. Okay, that's a bias. Advantages of a simple random sample. Very representative of the population, therefore accurate data. Disadvantages. Complete accounting of the population of interest is needed. Extremely difficult or impossible to get a complete list of the population of interest. Convenient sampling. This is what we did in our research project. Using a sample that is easier to find is convenient. We may have a list of some people who bought our product. A research company may have a list of people who bought specific products, including our product. Pretend like it's the iPhone and Apple. These lists will not include everyone that bought our product, but it is still many people. Since we do not know the total number and we do not have everyone's contact, this is a non-probability sample. Advantages. Convenient sample is much easier to find, faster results. Convenient sample is more cost effective. Disadvantage. Convenient sample is less accurate than a simple random sample. Now, you won't be tested on this exactly, but just think about it. If you knew the entire population and it was a pure simple random sample, you're going to be very accurate. But your convenience sample could be almost as accurate as a simple random sample, but cost you a 10% of the cost of doing the survey because you did a convenient sample. So the difference might be very small. And it comes down to the quality of the researchers involved and the access to the lists they have and how they use the lists. The list of contact people to do the survey. Referral sampling, also called snowball sampling. Find one person in the target and then ask for another name. Okay. Used for difficult to find targets. For example, Hungarians living in Doha, how could we find them? People who train falcons in Qatar, how could we find them? Remember the interviews, the different kinds of interviews, and we talked about expert interviews? This could be very good for expert interviews. So somebody who's an expert in falcon training in Qatar, you find that one guy, he's going to know other falcon trainers. So he's going to refer you. Okay, and that's another, that's called referral sampling, which is also non-probability sampling. Advantages, can get people from hard to find groups. Disadvantage, sampling is biased. People who know refer each other likely have similar opinions to each other. Okay, so they think in similar ways. Business research sampling reality. So this is what the real world is like. We can't use random sampling in most cases. That means risk in terms of sampling representing the population of interest. It's not going to be a perfect representation. We usually use a convenient sample method, but we make sure it is random as possible. Convenient sample will be more representative than referral. A research company database will be more representative than our company database. Unless, of course, maybe you're Apple and your research is even, you have even better research capabilities than a private research firm. This is a compromise approach, balancing feasibility, balancing the cost and time, and the representation of the population. Okay, sampling errors. Errors in the sample group compared to the population, asking the wrong people. Okay, example, I want to know how many students stay up late at night. So we're doing a research at the College of the North Atlantic. I want to know how many students stay up late at night. So at 7:30 a.m., I go out and do my survey. Well, the people that are going to answer that survey, I'm not going to have the right sample. Those who stay up late at night tend not to come to class early. Right? So I'm not going to find the people that I need to do this survey. And that would be a sampling error. Sampling errors can be reduced. Use more representative method of choosing the sample. Ask students in the late morning about staying up late at night. Increase the sample size. More chance of the sample being representative of the entire population, so by asking more people. Non-sampling errors, okay? Any error in results not caused by a sampling error, and generally these are human errors, the researchers making mistakes, okay? And these errors can be design errors. Respondents do not understand your questions in your survey. Your question is leading or biased. Data recording, data entry, and analysis mistakes. So you put the information in wrong, you analyze the information incorrectly. Okay, response rate errors. Very few people answered your survey. So these are errors. And when you find errors in your research, these go in your ways to improve future research section of your research paper. Okay, can non-sampling errors be reduced? So you can reduce human errors. Make sure the survey questions are clearly understood. That's why you do a test survey before you send out the survey to everybody else. You keep your survey short and interesting and minimize dropouts. Use computer-based surveys to reduce data entry mistakes. Okay, so sampling size. Exactly how many people do we need to do the survey? Okay, so there's a trade-off in asking how many. Too few people in the group, so if we ask not enough people, we risk sampling errors and poor data. Too many people, if we spend too long doing the research, we increase the time to do the research and the cost of the research. So how many should we ask? What do we need to calculate sample size? So we need to know the size of the population of interest. How many total people are in your target group? Confidence interval. Accuracy. How close to the truth? Is a plus or minus percentage. How confident do you want that population truth falls within your confidence interval? So do you want your data accurate plus or minus 5% or plus or minus 10%? That's the confidence interval. Okay, then confidence level, reliability. So confidence interval is about accuracy, confidence interval is about reliability. How often would you get the same result? What margin of error would be acceptable in your study? So the confidence interval is about the survey you are doing. How accurate is the survey you are doing? And the confidence level is if you repeated this survey again and you asked another group of 30 students and then you compared the results of both of your surveys. So you went out, asked 30 students, analyzed your data, then you went out and asked another 30 students, analyzed your data. How close are the two sets of data to each other? Okay, that's your confidence level. So how close to the truth do you want to be? Plus or minus 10%, plus or minus 5%, or plus or minus 1%? Assume our population is 100,000 people, and we select a 95% confidence level. Then the sample size required is, so if the population is 100,000 people, and a 95% confidence level, how many people do we need to ask to get a 10% confidence interval? How many people do we need to ask to get a 5% confidence interval? And how many people do we need to ask to get a 1% confidence interval? Can we afford a 1% confidence interval? We'd have to ask a lot of people to get a 1% confidence interval. So the more accurate you want your confidence interval, the more people you're going to have to ask. Now, how do we calculate these numbers? Well, here's the formula. Okay, so Z equals the value, example 1.96 for a 95% confidence level. P is the percentage, picking a choice expressing as decimal. 0.5 used for sample size needed. Okay, so we're assuming the 0.5, basically, we're not going to test you on this, means an evenly distributed population. Confidence interval expressed as a decimal, 0.04 equals plus or minus 4. But good for you. Back in my day, when we did this, we had to do it all on paper. There's a calculator that's going to do this for you. Okay, so I want you to go to this link right now. Okay, and I'm going to escape out of here. I'm going to put this over here. I'm going to go back to this question, the 100,000 population. Okay, And let's go to this link. All right. Okay, here is our sample size calculator. And back to here. Okay. So looking over at the sample size calculator. Okay, a confidence level of 95%. So what was our population? Our population is 100,000. Okay, confidence interval. So we had to put in our confidence interval. So confidence interval, 1, 5, or 10%. So confidence interval, it says here 10%. So you put 10%. So confidence level of 95%, confidence interval of 10%, population of 100,000. How many people do we need to ask? 96 people. All right. So you'd have to ask 96 people if your population is 100,000. And back over here, what if it was confidence interval of 5%? $383 people. And then confidence interval of 1%. This is incredibly accurate. How many people do you have to ask? Of the 100,000 people, you have to do 8,763 surveys. It's not feasible. So let's go back to that plus or minus 10%. And let's set the population at 2,000. So the School of Business population is 2,000. So if we had a confidence level of 95% and a confidence interval of 10%, you have to ask, you need a sample size of 92. Okay? We only asked you for a sample size of 25 or 30. Okay? So confidence interval, if we drop the confidence interval to 90%, the confidence level to 90%, the confidence interval to 10%, 66. Okay? So what is it? Okay, if we were to get to 30, okay? So the lowest this calculator lets us have is a confidence level of 90%. So if we had a confidence interval of 15, 30 students, okay? So that's not very accurate. So you have a confidence level of 90% and a confidence interval of 15. Okay, so that's plus or minus 15%. So when you do your survey, okay, and you only have 30 people answer your survey, you're operating on a confidence level of 90% and a confidence interval of 15%. That means plus or minus 15%. So if you're making a business decision, your confidence level is plus or minus 15% of what your survey said. So if your survey said 50% of students like my idea, well, that's plus or minus 15% of the students actually like your idea. So it's anywhere from 35% of the students like your idea to 65% of the students like your idea. And that's a big difference. Are you going to make a business decision where possibly 35% of the students like your idea? That's why you need these numbers to be as high as possible. That's why you want a higher sample size, right? So thinking about something like this, 240 students, you want to ask a lot of people to get accurate. Okay, but where we are in your survey, we're somewhere like this. We're actually plus or minus 15, somewhere about there. Okay, so your survey results aren't entirely accurate, but it's very convenient to collect. It's doable in the amount of time we've had. So realizing this, if you want really accurate data, you're going to have to collect 240 surveys. How long is that going to take you? Maybe a long time, right? So you need more than one researcher. Maybe as an entire class, you could go out and collect 240 surveys. Okay. So that's that tool. All right. So play with it and just, do other scenarios. And it's basically, this tool is running off of this formula. Okay, confidence interval. If we want more accuracy or less error, we need a larger sample size. We just discussed that. Confidence level. If confidence level tells you how confident or certain you can be with your results, or how often you would get the result if you did many samples of the same size, so if you repeated the survey to different groups. It represents how often the true percentage of the population who would pick an answer that is within the confidence interval. 95% confidence level means you can be 95% certain the results of your survey fall within the confidence interval. 99% confidence level. It means you can be 99% certain the results of your survey will fall within the confidence interval. Confidence level. There is nothing magical about confidence level you choose. It can be 90, 95, or 99. Most business researchers use a 95% confidence level. However, to increase the confidence level, you need to increase the sample size, which we just discussed. Okay, assume our population is 100,000 people and we set out a confidence interval of 5%. Then the sample size required is to get a 90, 95, or 100. Okay, we just did that. Can we afford a 99% confidence level? We're going to need a lot of researchers. We're going to need a lot of time. We're going to need a very willing population to answer our survey. We're probably going to have to offer a chance to win a free iPhone or something else to get them to answer this survey. Right? We're going to need a lot of people. Okay, so we just did the calculator. Okay, to calculate sample size, we need to select the target population size, confidence level, confidence interval. Sample sizes are not intuitive. We can't just guess them. That was that big Z-score formula that we just saw, or the calculator, the online calculator we used. CNAQ population for Qatar population example. Okay, calculate the sample size to get the opinions of adult Qataris. Okay, so research the population of adult Qataris. Find out what sample size, how many people do you need to ask to get the opinions of adult Qataris, and it to be somewhat accurate. Compare it to the sample size needed to get the opinions of CNAQ students. So he just did the School of Business at 2,000 students. How big is the difference in the number of people we have to ask? Use the sample size calculator specifying a 90% confidence level and a confidence interval of plus or minus 10% on both populations, Qatari adults and CNAQ students. What's the difference? Okay, improving your response rate. We want our survey to be representative of the population so we can make business decisions with more confidence. If we want more accuracy, we need a larger sample. If we want more confidence, we need a larger sample. Easy to say, very expensive and difficult to do. Okay, getting your numbers. 2 challenges in getting the required results. Response rate, percent of people who respond to your survey. Completion rate, percent of people who finish your survey. Some might start, but not all finish. Okay, often very low and will vary depending on the way you're contacting the sample frame. So for mail, if you send it out by post, only 5 to 10% of the people will answer your survey. Telephone, 15 to 20% answer your survey. Email, internet, 20 to 25%. And in person, 30 to 40% will answer your survey. But as you go down, you're going to see there's drawbacks. In person is going to be expensive. Email is probably the easiest, right? This might be the best solution. But without a person involved, how do you know they're just randomly answering the questions for you, right? In person will give you better quality. So this is a trade-off you have to decide what you're going to do. To make sure you achieve the required sample size, you send out more requests than you need. If the sample size required is 300 and the response rate you expect to be 25%, that means you have to send out 1,200 surveys. How to improve the survey response rate? Add an incentive, a gift, a prize, a contest. Okay, make the survey topic sound interesting and important. Follow up with those contacted, reminders. Okay, send out a second email asking them to do the survey to make sure they did it. Completion rate can be very high, but is very dependent on the survey design, how you design your survey, the wording, how you write your survey, ability of respondents to understand and answer questions, and the length of your survey. To improve the completion rate, follow the rules of designing a good survey and writing good survey questions. And that, my friends, is the end. I hope you enjoyed this, and this is the last lecture for MR 2300.